Today we'll discuss the second part of mathematical induction. 4 to the power of n minus 3 n minus 1 is divisible by 9. Let the given statement is true for n is equal to 1. This is our step number 1. Same as the previous one. The series is there. Now we are doing the divisibility test. So S of n, call it S of n equal to 4 to the power of n minus 3n minus 1. So n equal to 1 if you take 4 to the power of 0, 3 into 0 minus 1. So 4 to the power of 0 is 1, 3 into 0 is 0 minus 1 minus 1 is 0. So therefore, S of n is divisible by n. Therefore, S of n is true for n equal to 1. Let us assume step number 2. Step number 2, let us assume that S of n is true for S of n is true for n equal to k. That means 4 to the power of k minus 3k minus 1 is divisible by 9. Let 4 to the power of k minus 3k minus 1 is divisible by some multiple of m. So 4 to the power of k equal to 9m plus 3k plus 1. So please make a note. This one. Now step number 2 is over. Now step number 3. What is step number 3? We have to prove S of n is true for n equal to k plus 1. So S of k plus 1 equal to 4 to the power of k plus 1 minus 3 into k plus 1 minus 1. That means whenever n is there, we are writing k plus 1. This we can write 4 into 3 to the power of 4k minus 3k minus 3 minus 1. Now 4 into minus 3k minus 4. See here, this one. This part I am taking. 4 to the power of k. What is 4 to the power of k? 9m plus 3k plus 1. Now open the bracket, multiply. 4 9s are 36m plus 4 3s are 12k plus 4 1s are 4 minus 3 minus 4. Minus 4 plus 1 getting cancels. 36m plus 12 minus 3 is 9. 9k. So now 9 if you take common, 4m plus k. Again, it is some multiple of 9. So therefore, S of k plus 1 is divisible by n. Therefore, by mathematical induction, S of n is true for n equal to k plus 1. The same thing. Here we are also doing the same thing, but here we are proving the divisibility. There we are going by the induction process. This is also math. It is called mathematical induction, but we call it a complete induction for this type of the problem. So one more problem of the same type. One more problem of the same type. So 3 into 5 to the power of 2n plus 1, 2n plus 1 plus 2 to the power of 3n plus 1 is divisible by 70. So step 1, let the given statement and be S of n 3 into 5 to the power of 2n plus 1 plus 2 to the power of 3n plus 1 is divisible by 17. Let the given step. Now we will go step number 1. Now we will go step number 1. What is step number 1? S of 1, n equal to 1. 3 into n equal to 1, if you take 2 into 1 is 1. So 2 plus 1 is 3. N equal to 1. 3 into 1 is 3. 3 plus 1 is 4. So which is equal to 3 into 5 cube is 125 plus 2 to the power of 4 is 16. So now if you add them up, this goes to 391. 391 is 17 times 23. So therefore, this is divisible by 70. Therefore, S of 1 is 2. Therefore, S of 1 is 2 for n equal to 1. What is our step 2 assumption? Step 2, let us assume that S of n is divisible by 17 for n equal to k. So S of k equal to 3 into 5 to the power of 2k plus 1 plus 2 to the power of 3k plus 1. We are assuming it is 2. So let 3 into 5 to the power of 2k plus 1 plus 2 to the power of 3k plus 1 equal to 17 some multiple. So 3 into 5 to the power of 2k plus 1 equal to 17m minus 2 to the power of 3 plus 1. This please make a note. This we will be using. Now what the step number 3 says? To prove that S of n is true for n equal to k plus 1. S of k plus 1 equal to 3 into 5 to the power of 2k plus 1, 2k plus 1, k plus 1 plus 1 plus 2 to the power of 3 into k plus 1 plus 1. Okay. Now what I am doing, 3 into 5 to the power of 2k plus 1 into 5 square plus 2 to the power of 3k plus 1 into 2 cube. So this is 5 square, 25 Pi square is 25. 3 into pi to the power of 2k plus 1. 2 cube is 8 into 2 to the power of 3k plus 1. Okay. 25. You see, 3 to the 3 into 2 to the power. So let me change the color. This part. What we have you see here? This part. We are replacing this part by 17m minus 2 to the power. This I am replacing. So this will be 17m minus 2 into 2 to the power of 3k plus 1 n into 2 to the power of 3k plus 1. Now if you multiply 1725 into 17m minus 25 into 2 to the power of 3k plus 1 plus 8 into 2 to the power of 3k plus 1. So this is 25 into 17m minus, you see, minus this 8. So 17 into 2 to the power of 17 into 2 to the power of 3k plus 1. So if you take 17 common, 25m minus 2 to the power of 3k plus 1. So therefore s of k plus 1 is divisible by 17. So s of k plus 1 is 2. Hence by mathematical induction, f of n is 2, or s of n is divisible by 17 for all values of n belongs to natural number. Thanks for watching. Please subscribe my channel for more upcoming videos.